KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss next continuing problems So 19, 20 and 21, right? So we are going to discuss problem number 19, 20 and 21, okay, right. First we will see the problem number 19. See here, first I will read the problem, then I will go for solution. See here, the image of a small electric bulb fixed on the wall to a room is to be obtained on the opposite wall 3 meters away by means of a large convex lens. So first try to understand the requirement. Try to understand the requirement. Okay, right. The image of a small electric bulb fixed on the wall to a room is to be obtained on the opposite wall 3 meters away by means of a large convex lens. Full stop. Right. To achieve this requirement, what is the maximum possible focal length of the lens required for this purpose? For this purpose, right? For the purpose, okay? See here. So I hope you understood the situation, because understanding the situation is very important. Based on that we will go for solution, okay? Right. See here. See the solution ma. The minimum distance between an object and its real image. The minimum distance between an object and its real image is 4f. The minimum distance between an object and its real image is 4f. So that is what you can write 4f maximum is equal to d. 4f maximum is equal to d. D is, that is what, 3 meters of distance. 3 meters of distance, okay, right. But in this problem, what he is asking, what is the maximum possible focal length? So that f maximum is equal to d by 4. So when 4f maximum is equal to capital D, f maximum is equal to capital D by 4. So capital D is 3 no? Then 3 by 4 is equal to 0.75 centimeters, right? F maximum is equal to 0.75 meters, sorry, because d value given in meters, so no chance to get here centimeters, right? So it is also, because we substituted in meters now. So when we substituted in meters, and it is what a numerical value for 3 by 4 will give us 0.75 centimeters, okay, right. Next example problem, sorry ma, these are not example problems, these are exercise problems, right? So example problems already we discussed when we were discussing about the theory, okay. That's why these are all the problems from first problem onwards, that is what Ray Optics Numericals 1 onwards, right? So all are these exercise problems, right? Okay. Next 20th exercise problem, see here. First see the problem, then we will go for solution. See here. A screen is placed 90 centimeters from an object. A screen is placed 90 centimeters from an object. Okay, right. the image of the object on the screen, the image of the object on the screen is formed by a convex lens at two different locations. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeters. Full stop. Determine the focal length of the lens. Determine the focal length of the lens. That he is asking, right? So a screen is placed 90 centimeters from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeters. Full stop. Determine the focal length of the lens. Determine the focal length of the lens. Okay, right. You know very well, it is what ma? The distance from here to here is 90 centimeters. They only gave in the problem, right? Okay. So when it is 90, what about the value of x? X is the distance of first convex lens from object, and I is the distance of, that is what, here this side x is the distance of image, that is what, distance of screen from the lens to, okay. So when it is x, this is also x, right? So it is totally how much? 90 centimeters. So what can we write? X plus 20 plus x is equal to 90 centimeters. Then what about x mathematically? So 2x will become as 70 and x will become as 35 centimeters. 35 centimeters. Okay, right. And you can also see this picture here. O and I is the object and is the image. Okay, and L1, L2 be the two consecutive positions of lens. It is what L1 and it is what L2. Two lens are separated. Okay, right. Now, where the lens is in position L1, we have. So what we have? U is equal to minus x is equal to minus 35 centimeters, because already we found x is equal to 35 centimeters. And V is equal to, right? V is equal to 20 plus x. So it is 20 and it is x. So it will be 55 centimeters, right? So 20 plus x means what? 20 plus 35, because already we found x value. It will be 55 centimeters. Okay, right. So when it is 55 centimeters, that is what V, and it is what U, it is 35 centimeters. Therefore, 1 by F is equal to 1 by V minus 1 by U, right? So what is V? 55, and what is U? Minus 35. Already minus is here. You just observe carefully. Already minus is here, and it is also minus. So that minus of minus means plus, right? So it is 1 by 55 plus 1 by 35. So do that process mathematically, taking the LCM, right? Then you will get it as 1 by F is equal to 18 by 385. 18 by 385. Okay. So when it is 18 by 385, what about the value of F? It is 385 by 18. 385 by 18. It will give us 21.4 centimeters. 21.4 centimeters. It is the focal length. It is the focal length what he is asking. That is what, determine the focal length of the lens. Determine the focal length of the lens. So the focal length of the lens is 21.4 centimeters. 21.4 centimeters. Okay, right. Next problem. See here, it is what, problem number 21st. So 19th problem, 20th problem completed, and next problem number 21st. Okay, problem number 21st. See here. So it is somewhat lengthy problem. So first I will explain you the problem. You will listen carefully. Determine, see here, determine the effective focal length of the combination of two lenses in exercise 9.10. Okay. So while watching this class, you just go back to that 9.10 and once again you have to verify what is there. Okay. Determine the effective focal length of the combination of the two lenses in exercise 9.10. 9.10. If they are placed 8 centimeters apart with their principal axis coincident with their principal axis coincident. Full stop. Does the answer depend on which side a beam of parallel light is incident? That is the one. Next, is the notion of effective length of this system useful at all? That is the second one. Two things are here. So you please be concentrate. So the first thing is determine the effective focal length of the combination of two lenses in exercise 9.10. If they are placed 8 centimeters apart with their principal axis coincident. With their principal axis coincident, right? Full stop. Does the answer depend on which? Does the answer depend on which side a beam of parallel light is incident? That is one question like. And the second one is the notion of effective focal length of this system useful at all? That is the second one, right? So it is like A, it is like A, and there is another one, that is what B. See here. An object 15 centimeter in size is placed on the side of the convex lens in the above arrangements. In the above arrangements, right? Full stop. Next, the distance between the object and the convex lens is 40 centimeters. The distance between the object and the convex lens is 40 centimeters. Full stop. Determine the magnification produced by the two lens system. Determine the magnification produced by the two lens system and the size of the image. Right? So here also he is asking to find the magnification produced by the two lens system and the size of the image. So here also we have to find two things. To find these two things, he has given these two information. That is what one is 15 centimeters, right? Another one is 40 centimeters, right? So these two things they have given. See here. First we are going to solve the first one, the first part of the problem, right? See here. So what is the first one? Determine the effective focal length of the combination of the two lenses in exercise 9.10 if they are placed 8 centimeters apart with their principal axis coincident. Okay, full stop. Does the answer depend on which side a beam of parallel light is incident? Full question mark. Is the notion of effective focal length of this system useful at all? Okay, right. See here. See the solution, Let a parallel beam of light be incident from the left of the convex lens first. Let a parallel beam of light be incident from the left of the convex lens first. Then what is F1 is equal to 30 centimeters. F1 is equal to 30 centimeters. U1 is equal to minus infinity, right? So that you have to use that formula. That is what the lens formula. 1 by F is equal to 1 by V minus 1 by U. By using this formula, you can find out the V1. That is what 1 by sigma. See here, it's a formula. And then it is what 1 by V1 is equal to 1 by U1 plus 1 by F1. Right? Next, it is what U1 is 30. U1 is minus infinity, no? And F1 is 30 centimeters, no? So when there is plus, you can write anywhere, no problem, right? So that is what 1 by 30 minus 1 by infinity. So anyhow, it will be 1 by 30. When 1 by V1 is equal to 1 by 30, what about V1? It is plus 30 centimeters. Plus 30 centimeters. So using the sign convention, you just imagine because of this positive sign, where the image is. Where the image is, right? So because of this positive sign in case of convex lens, right, the image is, that is what image becomes a virtual object for the second lens, because there are two lenses in the combination, no? So that's why this image acts as a image acts as a virtual object for the second lens. Virtual object for the second lens. Okay, right. See here, next, f2 is equal to minus 20 centimeters. f2 is equal to minus 20 centimeters, and u2 is equal to right, because f1 is 30 centimeters now. f1 is 30 centimeters, and this is what they have given. They are placed 8 centimeters apart with their principal axis coincide. Okay, so here it is what u2 will become as 22 centimeters. 30 minus 8, right? So when it is minus 20, it is 22, and from the formula 1 by f is equal to 1 by v minus 1 by u, you can find out v2 by writing 1 by v2 as a subject. 1 by v2 is equal to 1 by f2 plus 1 by u2, right? So that here v2 is equal to minus 220 centimeters. v2 is equal to, you just substitute this values 1 by f2 means minus 20 and u2 means plus 22, right? So 1 by minus 20 plus 1 by 22, then v2 will become minus 220 centimeters. Minus 220 centimeters. Okay, right. Now the parallel incident beam appears to diverge from a point, that is what 220 minus 4, that is what 220 minus 4 is equal to 216 centimeters from the center of the two lens system, because the distance between the two lenses is 8 centimeters that they remove in the question they have given. But what about the distance from middle of the two lens system? It is what 4 centimeters now, and it is 220, and it is what 8, and 8 by 2 means 4. So finally 220 minus 4 is equal to 216 centimeters, right? So the parallel incident beam appears to diverge from a point 220 minus 4, that is equal to 216 centimeters from the center of the two lens system. Okay, that is what he is asking. Next, second one, in B only we are going to, in A only we are going to see the next situation. You just concentrate. See here, let the parallel beam be incident from the left of the concave lens. From the left of the concave lens, then what will happen? Here what? Let the parallel beam of light be incident from the left of the convex lens. Suppose, for example, if the parallel beam of the incident ray, that is what parallel beam be incident, right, from the left of the concave lens first, then what will happen, right? Because you know this is what minus 20 no, and u1 is minus infinity no. So by using this formula, 1 by v minus 1 by u is equal to 1 by f, right? So that we are writing v as a subject. So 1 by v1 is equal to 1 by u1 plus 1 by f1, and substituting these two, this is what 1 is 20, another one is infinity, and including the sign it will be minus, so that you will get it as u1 is equal to minus 20 centimeters. u1 is equal to, it is what v1, it is not u1, it is what v1. Okay, you just see here, see, so 1 by v1 is equal, that value we are getting now here, so it is what it is v1. So v1 is equal to minus 20 centimeters. Okay, right. So based on this sign, you can decide the position of the image. So where the position of the image? The image becomes a real object. This image becomes a real object for the second lens. Then you can go for next step, that is what see here, f2 is equal to minus 30, and u2 is equal to, already we got minus 20 no, so minus 20 plus 8, that is equal to what, right, minus 20 plus 8. Okay, so then what will happen? It is minus 28 no, right? So there is a bracket you observe carefully, right? There is a bracket, that is what minus 28, minus 20 plus 8 is equal to minus 28 centimeters, right? This is what because it is available in centimeters no, okay, it is also 8 centimeters and this is also centimeters. So anyhow it is minus 28 centimeters, right? I didn't write here the unit, but anyhow because of having this one and this one, that is what 8 centimeters in centimeters, this is also centimeters, right? Next, from this formula, that is what same, that is what length formula. You can write V as a subject means 1 by V2 is equal to, right? 1 by V2 is equal to 1 by F2 plus 1 by U2 and substitute these values, that is what here minus 30 and here minus 28 centimeters, and do that calculation. Okay. So by doing that calculation, you will get it as 1 by V2 is equal to minus 1 by 420. 1 by V2 is equal to minus 1 by 420. Then what about V2? V2 is equal to minus 420 centimeters. V2 is equal to minus 420 centimeters. See this. Thus the parallel incident beam appears to diverge from a point 420 minus 4, because it is 420 now. So 420 minus 4 means what? 416 centimeters on the left of the center of the lens system. On the left of the center of the two lens system. Okay. So this is what 1 and this is what 2, just to observe the difference between 1 and 2. Okay. I didn't write here, but I will tell you what is the difference. Okay. So based on the conclusion from first and based on the conclusion from second, you can say that the answer depends on which side of the lens system the parallel beam is present, right? So for this, what is this? Does the answer depend on which side of a parallel beam light is incident means? Yes. Yes, the answer depends on which side of the lens system the parallel beam is incident, right? Next, one more thing is there. Is the notion of effective length, that is what is the notion of effective focal length of this system useful at all? Okay. So the notion of effective focal length therefore does not seem to be meaningful for this system. Does not seem to be meaningful for this system here itself. Okay. Right. So it is what we completed A. Now we are going for B. See this. So what is B, Emma? An object 15 centimeters in size is placed on the side of the convex lens in the above arrangements. In the above arrangements, right. The distance between the object and the convex lens is 40 centimeters. Determine the magnification produced by the two lens system and the size of the image, right. So first B, U1 is minus 40 centimeters, no. U1 is minus 40 centimeters and F1 is 30 centimeters, right. So from this formula 1 by V minus 1 by U is equal to 1 by F. You can find out V1 as, just you substitute this value and this value you substitute here, so that you can find it as 120 centimeters. V1 as 120 centimeters, right. V1 as 120 centimeters, right. Next, if you observe carefully here, what is the magnitude of the magnification due to the first convex lens? Due to the first lens, that is convex here, right. So it is V by U, V by modulus of U, it will be 120 by 40, that is equal to 3. Next, see here, U2 is equal to, right, and based on this magnification plus 3, that is what 3, you can say that the image becomes a virtual object for the second lens. The image becomes virtual object for the second lens. So that what is U2 is equal to 112 centimeters, that is what 120 minus 8, that is equal to 112 centimeters, and F2 is equal to minus 20 centimeters, right. And substitute these two values in this formula by writing V as a subject, that is 1 by V2 is equal to 1 by F2 plus 1 by U2, so that you will get it as minus 24.9 centimeters, right. So by writing this here, that is what F2 value as minus 20 and U2 value as 112 centimeters, you will get V2 as minus 24.9 centimeters. Here also we have to find the magnitude of magnification due to the second lens. Second lens is concave lens, no, right. So here what is that? Modulus of V2 by U2, that is that will give you 20 by 92. magnification M2 is the magnitude of the magnification due to the second lens is M2. Just let us imagine, because due to the convex lens we assumed as M1 now. So here if you assume M2, according to this formula it will be 20 by 92. But in the question, after completion of these two, what he is asking, what is the, say here, determine the magnification produced by the two lens system and the size of the image, right? So net magnification, this is what the net magnification, it is M1 M2. Net magnitude of magnification due to the two lens system is M is equal to M1 M2, that is 3 into 20 by 92, that will be 0.652. You know very well magnification has no unit, right? So it is 0.652. Now what is the size of the image, right? Size of the image is H2 is equal to M into H1. H2 is equal to M into H1, then 0.652 into 1.5. 0.652 into 1.5, that is 0.98 centimeters. 0.98 centimeters. It is what size of the image, right? So it is the magnification due to the convex lens, it is the magnification due to the concave lens, it is second lens, and it is the net magnification, and it is the size of the image, that will be 0.98 centimeters. 0.98 centimeters. Okay. So the problem number 21 is somewhat lengthy problem. So you please be concentrate. In case of A, we did two things, that is what 1 and 2. After that we concluded, right? And then as usual, according to that question, we found, that is we found and we calculated the things what he is asking in the second half part of the problem, that is what here B. Okay, right. Okay, in this class we discussed 3 exercise problems, 19, 20 and 21, right? So in our next class we will continue remaining problems. Thank you.